Hi everyone, Wei here. Welcome back to the channel. In the last video, I compared Flux and Midjourney. Well, Flux outshines Midjourney and other previous stable diffusion models in many ways. It does have a significant downside. The generated skin tends to have a plastic-like appearance. For example, take a look at this image created using Flux. Even though I added a lot of details with LoRA to boost the realism, some parts still look fake. The skin texture on the face, for instance, isn't very convincing, and the direction of the whiskers doesn't look natural either. To address this, I developed a conveyor workflow that enhances images generated by Flux models. You'll find a download link for this workflow in the video description. This workflow has three standout features. First, it's fast. I didn't include the face detailer or any other resource-heavy detailers because Flux already demands a lot of memory, and adding those would only slow things down further. Second, it not only enhances the details of the face skin, but also improves the skin's texture across the entire body. Third, you can choose whether or not to enhance the eye details. Sometimes, Flux generates stunning eyes, but adding more detail can cause them to lose some of their natural light. The workflow is straightforward and divided into three groups. The first group is all about using Flux models to generate portraits. You'll notice that the skin on the generated portrait looks too smooth, lacking a realistic feel. That's where the second group comes in, adding more realistic texture to the skin. However, this process can repaint the eyes, causing them to lose their original glow. So, we have a third group to restore the eyes to how they originally appeared in the Flux-generated image. Now let's compare the final image with the original one from Flux. After adding these details, the skin on the face looks much more realistic, and the eyes remain unchanged. The hair is a bit messier, but that actually adds to the realism. The fine lines under the neck and the texture around the collarbone also look very lifelike. That's the general overview of how the workflow operates. Next, let's dive into each group and break down the logic behind them and how the parameters are set. The first group is based on the basic Flux text-to-image workflow with a few added notes. I'm using the Chanel FP8 checkpoint here, but you can use other Flux checkpoints too. I've also added a LoRA to enhance realism further. There's a download link for this in the description. Here's the prompt used to generate the image. I put it in a separate CR text node so that the clip text encoder in the second group share the same prompt. In the Flux basic text-to-image workflow, there's a node for setting the image size. I replaced it with a node that lets you select the SDXL image size, so you don't have to input the numbers manually. Flux supports various aspect ratios, so if you want to create images of different sizes, you can use the basic empty latent image node. This node controls the on-off state of the two groups on the right. Initially, you want to keep the two nodes on the right turned off. After you've generated a satisfactory base image with Flux, turn them on to enrich the details. Alright, that's it for the first group. Let's move on to the second group. This group starts by creating a skin mask. Then, we use an SD 1.5 model for image-to-image repainting of the skin, using the Epic Realism checkpoint, which offers a strong sense of realism. A LoRA is also added to enrich the details further. You'll find links to both the checkpoint and the LoRA in the video description. There's a node dedicated to masking the person. I've enabled the face, hair, and body switches, so the white areas in the mask include all three. It's not perfect at recognizing skin though. For instance, it missed the shadow areas on the chest skin and mistakenly identified highlights on a sports bra as skin. But that's okay. As long as it captures the key areas, it's enough to enhance the details there. Over-precision could actually slow down the image generation process. You can adjust the accuracy by tweaking the confidence parameter. The lower the value, the larger the mask area. Typically, we create masks for the face, body skin, and hair. If you are working on a headshot, you can turn off the body option. There's also switches below that let you mask clothing, accessories, or the background. But generally, we don't need to enhance those details since Flux already does a good job with them. The other parameters can be left at their defaults. To the right, you'll find some nodes for image-to-image repainting. With the second group of nodes, the hair, face, and body details are enriched. However, some of the highlight is lost compared to the original Flux-generated image. That's where the third group comes in to restore the eyes generated by Flux. You can skip this step if you prefer the eyes enriched by the second group. First, we use the face parse node to segment the face, including the hair. Then, we use this node to select the eyes and create a mask. The girl mask with blur node allows you to resize or blur the mask. Here you can see the segmented eyes. Once the eye mask is ready, use Image Composite Mask node to bring back the original Flux-generated eye. Now when you compare this to the previous image, you'll notice that while the skin is more detailed, the eyes remain unchanged. After this introduction, I hope you now understand how to download and use this workflow. If you run into any issues, feel free to drop a comment below. If you find this workflow helpful, don't forget to like the video and support more workflow sharing. Hope to see you in the next video.